Do you want me to introduce him?
Do you know George enough that you could do that?
Maybe.
Okay.
Okay, let's see. 50 years or so? Yeah, but we won't go there. Okay,
I'm not that old.
oh, goodness gracious. Like I said, we're not going to go there. Okay, this evening our speaker is George Nixon. George has been an active member with Montclair Bird Club for over 40 years. Uh,
Wow.
Not that old.
well, he started when he was a wee one. He's a retired high school science teacher. George has provided programs, his field trip experience, and his knowledge about birds, dragonflies, and nature in general to not only our organization, but New Jersey Audubon Society, New Jersey Odes when he led that group, and various other birding and nature clubs in the area. George and Valerie retired 5 years ago to Livingston, Montana, which is an hour north of Yellowstone National Park, to enjoy the natural beauty and the wildlife of the area. George has been an avid birder and bug photographer his entire adult life. Once he got to Montana, he decided to branch out and point his camera a bit further afield. So this program, the program he's doing this evening, will take us to look at some of those stellar objects he has enjoyed photographing from his own backyard. George, it's all yours.
Okay, thank you.
Hey, can we just all mute before we start?
Okay, you all got that?
Mhm.
All right. Well, moving out here to Montana, it became very apparent very quickly that the night skies here are just spectacular. We don't have the light pollution that you have there in New Jersey. So I decided to take up astrophotography, which is a completely different aspect of radio photography. And that's what this program is all about. Ancient light. Oops, where am I? There we are. All right, so we're going to start with some close by things, namely the moon, which is our nearest celestial neighbor. It's only 240,000 miles away on average. It was first visited by the crew of Apollo 11 on July 20th, 1969. I think almost everybody on air today could probably remember where they were glued to the television when that happened. Only a few other Apollo missions visited the moon after that, and a total of 12 people have walked there. Um, the moon is tidally locked to the Earth, meaning that it always shows one face to the Earth. The other side is always in darkness from our perspective, but it does move a little bit in a couple of different ways. It wobbles slightly around its axis, so that sometimes you can see craters that lie on the terminator. The terminator is the difference between light over here and dark over here. And this is one of those craters right here that you can see is actually on the dark side of the moon, but is lit because of this, what's called libration of the moon. It also moves slightly up and down as it orbits, and occasionally this causes some interesting events. For example, sometimes the Earth's shadow will fall on the face of the moon, causing a lunar eclipse. And lunar eclipses occur when the moon is full, never at any other phase. Depending upon where you are on Earth, you might either see a total or partial eclipse of the moon. But even during a total lunar eclipse, the moon doesn't fully disappear, but rather takes on a deep ruddy hue. During a partial eclipse, only a section of the lunar surface is covered by the Earth's shadow, as shown here. Unfortunately, this shot was taken through cloud cover, so it looks more like a crescent moon than an eclipse. But bear in mind, what you're looking at really is a full moon here. Moving slightly farther afield, we go to the sun, our next closest celestial neighbor other than the planets. It's an ordinary yellow star, and it's a bit farther from the moon. Fortunately, on average, it lies 93 million miles away, which is about 8 light minutes. In other words, it takes 8 minutes for the sun's light to reach us. The sun goes through cycles of sunspots about every 11 years. At one point in the cycle, there are few or no spots, and is known as the solar minimum. At the other end of the cycle, there are lots of sunspots and is known as a solar maximum. This year, we're currently in the solar maximum, and that will lead to a couple of things we'll see in a little bit. Now, those sunspots, to give you some idea of their size, most are larger than our planet. They're areas where intense magnetic activity inhibits convection and makes them cooler than the rest of the sun's surface. That's not saying it's going to be balmy there. It's just going to be millions of degrees. Each sunspot is comprised of two areas, the umbra and the penumbra. The umbra is the darkest part, and it's where the magnetic field is the strongest and vertical to the sun's surface. The penumbra is lighter and has magnetic field lines that are more tilted to the sun's surface than the umbra. Sometimes plasma, which is highly charged particles where the electrons have been stripped away, can flow out of one sunspot and connect to another by magnetic field lines. Hot plasma can extend out from the sun's surface many thousands of miles into what's called the corona. The corona is kind of analogous to the sun's atmosphere. They form giant loops that can sometimes be seen during a solar eclipse. Solar flares, on the other hand, are bursts of protons and electrons from the release of magnetic energy around those sunspots. The particles become part of the solar wind. The flares can cause blackouts in navigation and communication signals. And there's something called a coronal mass ejection, or CME. Going back in history, on September 1st and 2nd, 1859, the largest solar flare and CME in history was recorded. A CME is kind of like a cannonball moving in a specific direction. This became known as the Carrington event. Fortunately, there wasn't the technology back then that we have today, but it did knock out telegraphs all over North America and Europe. Some stations caught fire, and some operators received electrical shocks. They had to shut down the stations, but they even found out that because of the electricity flowing through them, they were still able to continue sending Morse code. If the Carrington event were to happen today, with all our modern technology, it would probably knock us back decades before we could fix it all. Those solar flares and prominences can lead to auroras. Now, this is really close to Earth, and it's perhaps one of the most spectacular and beautiful events associated with the flare. During the Carrington event, the aurora was seen as far south as Tahiti. Yes, you can there. You can determine if the aurora will be visible in your area by checking any website that has space weather. Yeah, there is a such thing as space weather. Two items that you want to look at are what's called the KP index and the BZ. Don't ask me what they stand for. They're in German and I can't even pronounce them. The larger the KP index, the farther south the aurora may be seen. A little while ago, we had a KP of 7 and you folks in New Jersey even got to see it. Those of you who are lucky enough. When the BZ index is south, that means the aurora borealis will form in the north because opposites attract. There's a third index called the BT, which measures the strength of the interplanetary field, and the larger the value, the better the odds of seeing an aurora. When an aurora does happen, get out your cameras and take some photos, because cameras are much more sensitive to color and low light than our eyes. Basically, we can't see at night color. The more varied colors can be seen in the photo. Different colors occur when different elements have their electrons excited by the radiation from the sun. The most common color to see is green, which is produced by oxygen at an altitude of about 60 to 190 miles up. Red is also caused by oxygen, but at a much higher altitude from 180 to 250 miles up. Blue and purple are caused by nitrogen at altitudes of 60 miles or less. One of the first auroras I saw here, there was this phenomenon also. It's called Steve. It's not named after a person. It's an acronym, and it stands for Strong Thermal Velocity and Strong Thermal Emission Velocity Enhancement. It looks like an aurora, but it actually occurs much farther south than the aurora does. The essential mechanism is exactly like an aurora, with electrons getting excited, but far from the aurora circle. With Steve, electrons pour into the ionosphere, and friction heats the particles and creates a glow like an incandescent light bulb, or like if you have an electric stove, how the coils glow orange. But perhaps one of the most exciting spectacles in our solar neighborhood is the total solar eclipse. People will travel from all over the world just to go and see it, and for good reason. I know a lot of people from Montclair Bird Club traveled to Texas for the past one. During a solar eclipse, unlike a lunar eclipse, which happens at a full moon, this solar eclipse happens at a new moon. By a quirk of fate, this is really bizarre, the size of the moon when it's closest to Earth is exactly the same size as the sun is far from the Earth. When things align just right, the moon's shadow will fall on the Earth's surface, completely blocking the sun. It does not happen instantly, however. It takes some time. First, there's first contact when the shadow of the moon just touches the sun. Then you get into a partial eclipse phase. Like sunspots, the moon's or Earth's shadow, for that matter, is comprised of two parts, the umbra and penumbra. Again, the umbra is the darkest part, and its path across the Earth's surface will determine the path of totality. The width of the umbra is usually about 300 miles. If you were in the penumbra, you would only experience a partial eclipse. You're almost there. As the moon moves eastish to westish, more and more of the sun will be covered. Remember, never look directly at the sun during a partial phase without using approved solar glasses, or if you are photographing, use an approved solar filter. Just before totality, there are a number of events to watch for. One of these is to watch for shadow waves crossing the ground. A few seconds before totality, you can glimpse the diamond ring, like you see here, and Bailey's beads. This is the last vestige of the sun shining through the moon's valleys and mountains. This only lasts a second or two, so watch carefully. And then comes totality. At last, the moment has arrived and totality occurs. You can take off your solar glasses and solar filter and enjoy the sight of the sun's corona. That's that white area you see all around the outside of the sun there. This is the only time you will be able to see this. If you look carefully around the edge of the sun, called a limb, you might also spot a solar prominence or a flare. Totality only lasts a few minutes, so enjoy the show while you can. If you miss the diamond beads, diamond ring or Bailey's beads, you can have a second chance as the moon exits the face of the sun. And if you've never seen a total eclipse in person, the next time one comes around, go see it because there's nothing like it in the world. Eventually, the show's over and you're on the way out. You've re-entered the partial phase again, and you have to put on your solar glasses and filters. And then you have last contact, and the moon shadow will then completely exit the face of the sun until the next time the Earth, moon, and sun line up. But there is another type of eclipse called an annular eclipse. It's slightly different. The moon doesn't orbit the Earth in a perfect circle, but rather traces an ellipse. That means at some point it will be farther away from the Earth, and that's called the apogee. At other times, it's closer to the Earth and is called the perigee. You can remember that by away, apogee, AA. When it is at its perigee and an eclipse occurs, it becomes a total eclipse. When the moon is at the apogee, an annular eclipse occurs. Until then, it looks just like any other eclipse. You have a partial phase and a solar eclipse total, and an annular is exactly the same. After first contact, the moon starts to cover the first surface of the sun. More and more gets covered. And if you didn't know, you would know what type of eclipse it was. Until, at the ultimate moment, the moon does not fully cover the sun since it's at its farthest away point and is not large enough. Instead, you will see a ring of fire, excuse me, encircling the moon, and it only lasts a few seconds. After that, the moon moves westward and re-enters the partial phase again. And again, do not remove your glasses or camera filters. And we're done with that. Moving farther away, and sometimes closer, are comets. These are comprised of dust and ice particles of different gases and are leftovers from the formation of the solar system about 4.6 billion years ago. Perhaps the most famous is Halley's Comet. I did not take this picture. This is a NASA picture, which appears about every 77 years on average. It was last seen in 1986. I remember being on the Cape Ann trip and seeing it up there. When I first moved here in 2020, in March, well, actually, yeah, this was well, it was first discovered in March of 2020, but I saw it out here. Comet Neowise proved to be one of the best visible comets in recent history. It's a long period comet, since the next time it will be around will be about 6,800 years from now. I might be around, but I don't know if any of you will. Other comets, like Halley's, are short period comets since they come relatively frequently. Comets have a few parts. At the head of the comet is a solid icy core called the nucleus. As it approaches the sun, it starts to vaporize and forms a fuzzy region around the nucleus called the coma. As dust and gases stream away from the nucleus, the solar wind pushes back to form two tails. And you can see the one tail here that appears whitish. That's a dust tail. What you may not be able to see, I'll try and point it out here if you see my cursor, right here. It's very, very faint in this photograph, but that is an ion tail, and it appears bluish. It is made of electrically charged particles. So where do comets come from? They originate outside the solar system in two regions. The near is called the Kuiper Belt, and 50 times farther out from that is the Oort cloud. The Oort cloud is comprised of icy debris that can produce comets. And to give you an idea here we have our solar system. Here, this outer ring is Neptune's orbit, and then we have the Kuiper Belt. And then surrounding the Kuiper Belt, we have the Oort cloud, and that's where a lot of these things come from. This comet has a great name, C2022 E3ZTF. In 2022, this appeared as a non-periodic comet. The last time this was in our neighborhood, it was 50,000 years ago. Unfortunately, I don't remember that one. It didn't put on a great show and was a very, very difficult binocular target. But it does show the comma, but never really sported a tail. And the green comes from a form of carbon that's being ionized there. And I did a little touch up here to make these stars a little bit more visible. So if they look a little bit funny, that's why. Constellations. There are 88 modern constellations, of which 43 lie in the northern hemisphere. Many people can recognize the Big Dipper, but believe it or not, the Big Dipper is not a constellation. In reality, it's called an asterism. An asterism is a recognizable pattern, but not officially a constellation. The Big Dipper is part of the constellation Ursa Major, the Great Bear. Many of the stars that make up the constellation are quite faint and may not be visible from a light-polluted area. Ursa Major represents a circumpolar constellation that's visible throughout the year. In winter, perhaps one of the most recognizable constellations is the Orion constellation. Orion the Hunter does contain the Great Orion Nebula, which is visible to the naked eye and is pointed out here. It's about in the middle of the sword of Orion. But most people just recognize Betelgeuse and Rigel, these two stars, the belt and the sword, as being Orion, but that's not all there is to it. There are other stars too. There are stars that make up an arm and a shield that are often overlooked, and an arm up here. But again, because if you're in a light polluted area, you probably are not going to see those stars. Every star that you see in the sky when you look up at night is in our galaxy, believe it or not. You cannot see a single star in another galaxy. Everything you see is from our galaxy. And that's what we'll look at next. Galaxies. These are deep sky objects. Distances and sizes become incomprehensible. To get around this idea, let's use a scale model and some basic ideas. First, we often measure distance in light years, or how far light travels in 1 year. Now, 1 light year is equal to about 6 trillion miles, and that's even a number that we can't comprehend too well. So let's assume that the sun is the size of a period at the end of a sentence. That would make the Earth the size of a bacterium and would be about 1 inch away from that dot, the sun. At that scale, it turns out that 1 light year would be equivalent to 1 mile. If we apply that to our nearest star, Proxima Centauri, which is about 4.3 light years away, at our scale, it would be a dot 4.35 miles away from the dot that represents the sun. Our galaxy, the Milky Way, is a barred spiral galaxy, but we can only view it edge on since it's our home galaxy. It's quite large, being about 87,000 light years across. So I'll get a little bit ahead of myself. So when I say it's 87,000 light years across, it would take 43,500 years for light from the other side of our galaxy to reach us. So when we were looking at, if we could see the other side, we'd be looking back in time 43,000 years. Where are we? Right there, in the unfashionable Orion arm of the Milky Way. That's our solar system. The Milky Way is part of a larger structure called the local group, and there are 2 other members, large members of the local group. Every single star we see is here. The next closest galaxy to us is the Andromeda Galaxy. It's the second member of the local group and has a larger diameter of 152,000 light years and lies 2.5 million light years away. So when we look at this through a telescope, we are seeing the Andromeda Galaxy as it was 2.5 million years ago. It has 2 large satellites, M32 and M110. M stands for Messier. More of that later. And it's believed that another large galaxy smashed into Andromeda about 2 billion years ago. The surviving remnant is M32, located not far from the galactic center, relatively speaking. And the Milky Way, believe it or not, and the Andromeda Galaxy are supposed to collide in a couple of billion years. And that would be an incredible sight to see looking up in the night sky. But unfortunately, by that time, our sun will have burned out all its fuel and Earth will no longer exist. The next member of our local group is called the Triangulum Galaxy, M33. It is 3.2 million light years away and about 61,000 light years in diameter. The speed of light, just a little bit of physics here, well, is extremely fast, is not unlimited. And unless if our physics is wrong, it's the fastest anything can travel. Its speed is 186,000 miles per second. It can travel around the Earth 7 3/4 times in 1 second. Since the sun is 8 light minutes away, it takes 8 minutes. We see the sun look like it was 8 minutes ago. We see the Triangulum Galaxy like it was 3.2 million years ago, hence the name of this program, Ancient Light. But galaxies come in a wide variety of shapes. This is IC10. A lot of these things don't have names, they're just catalog numbers. IC10 is an irregular galaxy located in the constellation Cassiopeia. It is one of 80 plus smaller members of the local group. The IC designation tells us that it is in the index catalog, one of hundreds of catalogs for space objects. And it gets really confusing because you go look up something in the NGC and you find out it's also in like 5 other catalogs and you don't know what the heck it's called. Irregular galaxies do not have a distinct shape, such as spiral or elliptical. There's also no indication of spiral arms. They are thought to make up about a quarter of all the galaxies. The distance from us is about 2.5 million light years. That's about 5,000 light years in diameter. And it's the only starburst galaxy in the local group, meaning that it is experiencing an unusually high rate of star formation. The fireworks galaxy, also in the local group, while seemingly large, is actually a small part of a larger structure called the Virgo supercluster. The fireworks galaxy is so named because 10 supernovas have been observed there since the 20th century and early 21st century. A supernova, if you don't know, is a star that explodes in its old age. It lies 25 million light years from us and was once thought to be part of the local group, but now thought to reside in the Virgo supercluster. The Virgo supercluster contains 100 galaxy groups and is about 110 million light years in diameter. This is one I really wanted to photograph. Not all galaxies are face on or nearly so. I'll show you a couple of different versions of this type of galaxy. It shows a super thin disk morphology, and we see it edge on. It is warped like a potato chip or a music record that was too long in the sun. And some degree of warping is observed in a large fraction of the galaxies, but only a few are warped as much as this one. The odd appearance is likely caused by the galaxy's relatively small mass being twisted and contorted by the peculiar neighboring galaxy, which you can see, that didn't, right down here. That's also another galaxy. Another theory comes from a study published in 2004 that speculates the appearance may have been caused by an infalling satellite galaxy. In other words, a galaxy that got eaten by it. The Silver Sliver Galaxy is another edge on. And this is how we see the Milky Way from our vantage point. There's a large dust lane that you can see right down the middle there. Another name for this is called the Outer Limits Galaxy, because some of you may remember a show called The Outer Limits, and this appeared in the end credits of that TV show. The Whale Galaxy is another barred spiral galaxy, though you cannot tell from looking at it really. The most massive stars that form in star formation region only burn hydrogen gas through fusion for a short period of time, after which they explode as supernova. And so many supernovae have exploded in the center of this whale galaxy, designated NGC for New General Catalog 4631, that they're blowing the gas out of the plane of the galaxy, and you can see some of that gas around the left and the right edge. Now, you can't smoke the cigar galaxy. It's a little bit big. It's another star-forming galaxy about 12 million light years away. It was once thought to be an irregular galaxy, but by using near-infrared light, 2 spiral arms were discovered in 2005. The most unusual thing about the cigar is that in 2010, an unidentified object was discovered sending out radio signals, and they're not quite sure what that object can be. It's probably not extraterrestrial life, however. It's probably something more mundane like a black hole or something like that. Now, sometimes you can see large groups of galaxies. This is Markarian's chain. It's a stretch of galaxies that forms part of the Virgo supercluster. There are at least 7 galaxies in the chain that appear to move coherently with each other, although others appear to be superimposed by chance. 6 of the points on the chain can be marked by galaxies, and the other 2 points are pairs of galaxies. And you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this, and there's a couple more that are just out of frame. And there's probably a few more distant ones like here and here, these two, some up here. It's a pretty awesome sight to see. This is a very weird galaxy, NGC 660. It's called a polar ring galaxy. Most spiral galaxies will rotate like a record around this equatorial axis, but polar ring galaxies rotate end over end like a record flipping like this. They're thought to form when two galaxies gravitationally interact with each other. Here we have a face-on view of a barred spiral. You can see the bar down the middle and then the spiral arms on the edges. There's a couple of theories about how these form. One of them is called the density wave theory. The spiral pattern rotates at one particular speed, while the stars in the galactic disk rotate at a different speed depending upon their distance from the galactic center. Think of it like how cars, as traffic increases, will slow down, and then as the number of cars decreases, it speeds up. So part of it's moving fast, part of it's moving slow. Here's a pair of galaxies that have undergone collision, and they're quite distant past, and both have an incredible number of star-forming regions. You can see in the blue and kind of dusty areas in the center there, along the facing side of each galaxy. Despite having already collided, it's highly unlikely that any two stars actually hit each other in the process. And that just goes to show you how far apart stars are in terms of distances with each other. Here's one of my favorite ones to photograph, the Whirlpool galaxy. It's actually a pair of galaxies. It was the first galaxy to identify as having a spiral structure. One of the arms is pulled loose by the gravitational force of the small companion galaxy on the top, which is NGC 5195. The two galaxies are located about 25 million light years from Earth. You could actually see this with binoculars if you're in a fairly dark sky area. Other objects that we might find at night are nebula. A nebula is a distinct part of interstellar space that is luminescent and consists of ionized, neutral, or molecular hydrogen and cosmic dust. Sometimes, excuse me, these contain star-forming regions like galaxies. These structures have very, very low density. A nebula the size of the Earth would only weigh a couple of pounds. Nebula are classified into different categories. The name is a misnomer. The dumbbell is a type of planetary nebula. It is not related to planets at all, but rather because they tend to look roundish like a planet. The dumbbell was the first one discovered of this type. Don't mind the cat here. Its central star is a white dwarf, which you can just barely pick out right there. It can also be seen with binoculars. Besides hydrogen, which is responsible for the red colors, blue is caused by oxygen, and any yellows would be caused by sulfur. All right, there's got to be a couple birds here because this is a bird club program. So we have the Owl Nebula. You all can see the owl there, right? Yes, and neither can I. There's dark spots here and here are supposed to represent the eyes of the owl. It's a planetary nebula. It resides about 2,000 light years away. It's very young by comparison. It's about 8,000 years old. It was formed by the outflow of material caused by the stellar wind of the central star. Again, you can see that right there. The central star is a white dwarf, and they have about the mass of the sun, but in the volume of the Earth. There's a number of things that are very well photographed. This is one of them. The Ring Nebula is a combination of a planetary and an emission nebula. An emission nebula is formed from ionized gases that emit light at different wavelengths. These gases are usually ionized by high energy ultraviolet radiation from a nearby star. The color depends upon the gas and the degree of ionization. If you've ever seen a neon light, and we all see neon lights, they come in different colors. All those colors are not neon. The red ones are neon, and then the other colors are some other gas, like hydrogen or nitrogen or oxygen, something like that. Another bird, here's the Eagle Nebula. Yeah, if you use your imagination, here's the tail. Here's a wing. And it lost its head for some reason. Here's the other wing. But there we are. The Eagle Nebula, located in the Sagittarius arm of the Milky Way, vaguely resembles a bird in flight. It's an emission nebula about 5,700 light years away. You might remember seeing this photo by NASA and the Hubble Space Telescope. This is called the Pillars of Creation. And in this photo, the colors are brought out using hydrogen, oxygen, sulfur, and other filters. What may be surprising is that it can still create invisible light. If we zoom in, this is my shot of that same area, Pillars of Creation. It is a large star-forming region, especially the tips of those big dust clouds that you can see there. The Cocoon Nebula is both a reflection, is another type of nebula, and an emission nebula in the constellation of Cygnus. It is also associated with the Dark Nebula that you can see over here and over here. And more of those in a minute. And it's comprised of dust that is just barely visible. A reflection nebula, like the name implies, reflects the light of a nearby star or stars. The light doesn't have enough energy to ionize the gases, causing them to glow. In this case, both factors come into play. Well, I was talking about supernovas before. The Veil Nebula is a supernova remnant. It's a cloud of heated ionized gas in the constellation of Cygnus. It consists of the visible portion of the Cygnus loop, the supernova remnant, and many portions have acquired their own individual names and catalog identifiers. There's the Eastern Veil, there's the Western Veil, there's Pickering's Triangle, and a couple of other parts in it too. The source of the supernova was a star about 20 times more massive than our sun, which exploded between 10 and 20,000 years ago. At the time of the explosion, the supernova would have been visible in the daytime, being brighter than Venus in the sky. The remnants have expanded over to cover an area roughly 3 degrees in diameter, which is about 6 times the diameter or 36 times the area of the full moon. Previous distance estimates range from about 1,200 to 5,800 light years, but a recent determination of 2,400 light years is based on direct astrometric measurements. Try saying that 3 times fast. Another favorite object of mine is Thor's helmet. This is an emission nebula some 12,000 light years away. And it resembles kind of a Viking helmet with horns. The central star I've pointed out here is called a Wolf-Rayet star. These are rare stars that show an unusual spectra of hydrogen and highly ionized nitrogen, carbon, silicon, and oxygen. They have lost their outer hydrogen and are fusing helium and heavier elements in the core, which means they're going to blow up pretty soon. And what the Thor's helmet is that blown off gases that have been lost. So every star with an initial mass of about more than 9 times the sun will inevitably result in a supernova explosion. This is a constellation. Well, is it a constellation? I think it's just an open cluster called the Pleiades. Open clusters are loose groups of gravitationally bound stars, and could number anywhere from 10 to a few thousand stars. Pleiades is also known by the name of Seven Sisters for the number of the main stars that make it up. Though not all are usually seen with the unaided eye. Sometimes you can see six with the unaided eye, and it used to be a kind of like the old-fashioned eye chart. If you could see the seventh star, you had pretty good eyesight. But some of the stars also exhibit a blue nebulosity from the dust that surrounds all the Pleiades. Any of you drive a Subaru? That car is named for this cluster, the Pleiades. The Bubble Nebula, NGC 7635, is about 11,000 light years away. And the bubble you can see there in the center is about 10 light years across. So remember, each light year is 6 trillion miles, so that's 60 trillion miles across. And is created by the fierce stellar wind from the hot, young, massive central star. It blasted out the structure of glowing gas against denser material in the surrounding molecular cloud. That's that reddish area that you can see beyond it. But not all nebula are like this. Whoops, that's the central star. This is a dark nebula. And these appear as irregularly shaped dark patches in the sky and are comprised entirely of dust that blocks out the light of the stars that lie beyond them. If that dust wasn't there, this entire photograph would kind of look like this. And I counted there are over 64,000 stars in that photograph. I didn't count. I had my machine count it. This is a really cool one. This is anyone? Oh, it's up there. Dark shark. The dark shark is part of a huge molecular cloud and constellation Cepheus. Within the nebula, there are two reflection nebula, VDB 149 below the shark's head, which should be right about, come on, somewhere around about here, and one up in here, which is VDB 150 above the shark's head. The shark's nose has a dark nebula in it, designated as LDN 1235. Honestly, these are great names. And there's a lot of other faint nebulosity, bright stars, and a small spiral galaxy that you can see. Let's see if I can do it right there. Off to the right of the shark's head in this field of view. When I photographed this, I didn't even know if I had it in the frame because I couldn't see it. It's that dark. And it's only when you do it in post-processing that you can bring out this dust. This is one I really wanted to photograph. The Horsehead Nebula. This is a very famous one. I'm sure you've all seen pictures of this at some point in your lives. It's a dark nebula composed of dust and is another star-forming region. Again, it's not possible to see the protostars, but yes, that are in this dust cloud. Just below to the left is a reflection nebula. That's the blue one, called NGC 2023, and the big yellow one off to the right is the Flame Nebula. Scottish astronomer Williamina Fleming was one of the first influential women astronomers, and she discovered it back in 1888. It has been featured in pop culture many times, ranging from Doctor Who, if you're a Doctor Who fan, yay, to Wall-E and the children's animated series Widget. Orion is surrounded by the Orion Molecular Cloud Complex, and there are about 800 new stars forming near the center. This is probably one of the biggest nebulas we could see in the northern hemisphere, the Orion Nebula. It's also one of the most studied and photographed objects in the night sky. The nebula has revealed much about the process of how stars and planetary systems are formed by collapsing clouds of gas and dust. It can be classified as diffuse as there are no clear boundaries, and is so large that it is visible to the unaided eye, appearing as the middle star that I pointed out in Orion's sword. Other objects. besides galaxies and nebula, there are a few other structures in space, not to mention there's a plethora of different star types, brown dwarfs, red giants, black holes, quasars, magnetars. There's a whole zoo out there that I'm not going to get into, but you should look those up because they are quite interesting. M3. The M stands for the name of the French astronomer Charles Messier, who cataloged over 100 nebula and star clusters and then published the final version of the catalog in 1781. M3 is what's known as a globular cluster, and it's a large group of stars that are bound together gravitationally and has a higher density of stars toward the center. They're found in nearly all galaxies and reside in a region called the galactic halo. The galactic halo is clearest in spiral galaxies, and it's a nearly spherical region surrounding the disk. Globular clusters look fairly similar, but vary in size. M3 is a radius of 90 light years and it's 34,000 miles. 34,000 miles, yeah, sure. We'd be dead. 34,000 light years away. And all those blue stars that you see in there are hot young stars. There's a different globular cluster. This one is a really, really cool one, Hercules cluster. It looks larger than M3, but M3 is actually larger, but it's farther away. Again, there are lots of hot blue stars sprinkled throughout the cluster, and there are a couple of red giants that you can see, especially near the outer portions of the photograph. These are very large stars of lower, I'm talking about the red giants, of low or intermediate mass that are in the old age portion of their life. In 1974, I don't know how smart this was, a message was sent in the direction of the Hercules cluster that contained information about humans, DNA, where the Earth is, come and get us, we're here, we're good for eating, in hopes of contacting other life forms. But it is debatable whether the cluster will be in the same position when those radio waves get there. Because remember, radio waves is just another form of light, and that's traveling at 186,000 miles per second. So it's going to take however far away this is, which I don't know off the top of my head. Okay, here's another bird, another owl. The owl cluster is an open cluster in the constellation Cassiopeia, about 8,000 light years away, and it's about 21 million light years old, and sometimes called the ET cluster after the alien in the movie. Sometimes it's a bit difficult to see the shapes that scientists or astronomers have given these objects, unless, of course, you've been doing lots of serious weed. So I'm going to help you out here and show you the owl. Does that help? Here's what I'm not going to help you out with. Caroline's rose. This is another open cluster discovered in 1783 by Caroline Herschel. Unfortunately, the rose pattern is less discernible in a photograph than it would be if you were to observe it visually. And last but not least, we can wind up with a double cluster. And this double cluster is visible to the naked eye. It's at a distance of about 7,500 light years in the constellation Perseus. An interesting story here, Perseus, or an interesting myth, Perseus was a famous hero of Greek mythology, son of the Greek god Zeus. Along with beheading Medusa, Perseus performed other heroic deeds, such as saving Princess Andromeda, who was chained to a rock as a sacrifice to the sea monster Cetus. The gods commemorated Perseus by placing him among the stars with the head of Medusa in one hand and the jeweled sword in the other. The double cluster represents the jeweled handle of the sword. Well, if you want to know how I did all this, this is the observatory in my backyard. I had to get my observatory because there are some neighbors that just leave their lights on every time they put their dogs out, and it was driving me crazy. And the equipment that I use, I have two sets of telescopes. My big one is a Celestron C11 11-inch scope. We have a guide scope up here that helps keep me on target. The guide camera. This is my little computer that runs the whole thing. This is my main camera here, and what's called a harmonic or strain wave mount here. My small camera, here's the main scope. Guide scope is here, guide camera here, main camera here, and the computer is down here. So there we go. And that concludes my program on what's out there. So if you have any questions, I'll make up the answers because I'm sure I don't know because I'm not an astronomer. I just like taking photographs.
Wow. Questions for George?
Have you discovered anything new?
Many things. That's why my name is on them all. No.
You mentioned something that's going to explode soon. How soon is soon?
Well, nobody knows that for sure. Are you familiar with Betelgeuse in the constellation Orion? It makes up his upper left-hand shoulder. That's been doing some weird things over the last couple of years, and they suspect that that might go supernova anytime in the next year to 10,000 years. So it happens. Some people just get lucky. The way to discover them is to photograph the same thing, the same galaxy, night after night after night, every time you can, and look for a change where one star gets brighter than the rest that hasn't appeared before. It would be very dangerous for a star that would be close to us to go supernova, because it could probably wipe out all life on Earth if it did so. But fortunately, even Betelgeuse is far enough away that we don't have to worry about it.
George, in your pictures of the eclipse, sometimes the sun is kind of yellowish and sometimes white. Is that filters on yours, or is that the actual color?
That's the actual color. Well, if you saw any part of the sun's disk, I was using a solar filter because otherwise it would burn out my camera. When the totality came from Bailey's beads and the diamond ring on, that was all unfiltered. So part of it is probably a bit of exposure, because I was just had my finger on the trigger and was shooting away. But
Really?
astrophotography is a completely different ball game than regular photography. For every one of those pictures that you saw, I had to take anywhere from 20 to several hundred pictures. On top of that, then you have to take what are called calibration frames, which are called and collectively darks, flats, and bias frames. And those are designed to get rid of any noise and defects that are in the pixels of the camera. Then you take all that, you stack the photos, and the processing software will do a lot of this stuff for you automatically. And then after you get that done, then you could actually process the photograph to where you could actually bring out some of the details. So for me there's a program called PixInsight that is a dedicated astrophotography program, and it is wonderful. But it is also exceedingly complex. But it takes me roughly, depending upon how many pictures I had to stack, anywhere from 2 to 4 or 5 hours to process one picture.
How come we don't see any satellite trails?
Because in PixInsight, I have it set to get rid of satellite trails. And
That's
any bright satellites like the ISS, I just throw those pictures out because it's too bright and it can't deal with it.
George, the comets that you displayed are losing matter as they move through space.
That's
Do they
correct.
get replenished in any way, or is it just almost an endless amount of losing matter without just becoming
No,
nothing?
they do lose matter. In fact, Halley's Comet, if you compared it, the descriptions back in, when was it, early 1900s, subtract 77 from 1986, and you'll have the year. It was a much larger and brighter comet than it was in 1986. Um, and comets are notoriously unpredictable. You never know when you're going to have a great comet. The last one that we had, what was it, just a few months ago in October, that was a pretty darn good comet. And that wasn't even a great comet, just a pretty darn good one. So what happens is, as the comet moves around the sun, it can actually break up so that when it comes back around, it's not there anymore, it's gone. So every time it gets closer to the sun, you see those tails, that's mass that's being lost. And the meteor showers that we see with the Perseids, the Aedes Aquarids, and all those others, we are passing through the dust remnants of a comet's tail. And that's what those meteors are. So any comet may or may not make a complete revolution around the sun. It may break up. It may completely disintegrate. It may slam into, there was a Shoemaker levy back in the 80s, slammed into Jupiter. So you never know what's going to happen with them.
I have a question about your planetarium. Is that what they call it? The thing in your backyard?
Observatory.
Observatory. How does that, this is a stupid question, but how does that keep the light out? Because isn't the light still, your neighbor's light still shining on your telescope?
No, I don't know if it was visible. I'll show the screen again and let's go back to that. One more. Okay, yeah. You see this spot right here? This is actually the back side of a shutter. So this slides down. So this half and this half are always covering. And if you imagine nothing here, this is where the telescope would be pointing through. The bad thing about that particular system is if I'm not shooting due north, I have to go out and rotate that dome about every 15 minutes to make sure the telescope's pointing through the opening rather than the inside of the observatory.
Does it spin around on its own or do you have to do it yourself?
You have to do it yourself. There is a kit that you can put on that will rotate the dome, but I don't think it would work tracking the stars because we need a GPS to know where it was. Because if I'm shooting north, basically those stars are circumpolar and they're only moving a few degrees through the course of the night from east to west. So they're moving like this, but they stay in that opening. But if I'm shooting south, they're moving the entire arc of the sky. So the dome would have to know where it was pointing in order for it to be synchronous with the movement of the stars. And I have to do it manually.
And is it a dual purpose one of these? Is there something else you could do in here besides look at stars? I'm just thinking that's a lot of like I don't know, ice fishing maybe, or like, is it your
Well, I'm gonna put my hot tub in there eventually.
You can move the hot tub a little closer.
I could, but it is pretty close.
So I noticed that it seemed to me that there was only one image that had red in in it, and that was the cigar galaxy. Why would that be?
Um, the well, part of it is probably a lot of dust, and it also may be some type of emission nebula in there too, but it's more than likely just a matter of dust.
I have one more question, and I forgive me if this is a little personal. Is this an expensive hobby?
Let me put it this way. Yes. If you just want a telescope to look at the stars and planets, you can get a fairly good telescope for about $800. Don't ask me how much money I've sunk into this because I'm constantly upgrading my equipment and the harmonic drive, and the scope actually wasn't terrible, but the harmonic drive, the cameras, the computers, the software, it adds up.
The observatory.
The observatory, yeah, but you don't need the observatory. If I lived a little just outside of town, I wouldn't need an observatory. Or if my
Amazon
neighbors
right
were less,
I'm on Amazon right now, and they have inflatable observatories for under $1,000, and they also you can it works as a bouncy house.
okay then. That probably would not be too great for astrophotography. But here's the thing. When you look at or through a telescope visually, you are not going to see what I showed you tonight. You are not going to see any of those colors. That's all because a camera is much more sensitive to our eyes. We're basically colorblind at night. So most everything that you look at is going to look like a gray smudgy. So don't expect to buy like an 8-inch Dobsonian telescope and see what I showed you. I mean, you'll see some of those things, but you're not going to see that like I showed you.
So George, it's Betty. When you're doing this, are you sitting at your computer and directing things that are
Oh,
happening?
heck yes, I'm doing this inside the house.
Oh, okay.
The only thing I have to do outside is I have to get the polar scope aligned to true north, and then I have to tell it where it is. After that, if it's 35 below outside, I'm inside the house.
And so you're just like saying, okay, moved like 3 degrees right, or and take a picture now.
That's all done by the computer that I have on telescope. Once I have my target locked,
I see.
I told the computer how many shots I want to take, what gain I want to use, how long I want the exposure for, and I just sit there in my dining room and I look at the pictures coming up on my iPad.
Wow. This was a lot to learn.
It is, and I'm still learning.
You should mention to them that a lot of the equipment that you purchased came right from Sussex County, New Jersey, even though you're in Montana, because there is
Oh yeah,
best suppliers right here in New Jersey for those.
High Point Scientific, I highly recommend them. They're up on Route 202, not too far from
206.
206, not too far from
Us.
Water Gap. They're on the left-hand side as you're going north.
So if anyone in New Jersey wants to get involved, it's easy to go up there and check out their equipment. Any other questions for George?
So you're doing this alone out there, George, or is there a whole community also doing astrophotography?
There is a group out here called Southwest Montana Astronomical Society, which I have a meeting in 6 minutes.
Thank you. Goodbye.
And I met this one guy. He goes down in the valley. He's interested in astrophotography, so I was working with him And there's one or two other astrophotographers in the area. This guy I met up in Wilsall, which is a very small town about 40 minutes north of me. So there are a few of us around.
All right, last question for me. Big picture question. From doing all this, do you feel there's another, there's how do you explain it? The UFOs, is there another community of people somewhere in this world? Do you feel is it
In
just
this
us?
world, no.
In another world, in another
In
galaxy far away?
Absolutely. It's preposterous. There are hundreds of billions of galaxies that contain hundreds of billions of stars, and we're finding more and more exoplanets as the years go by. And for us to be the only life in the entire universe is absolutely preposterous. But what people don't realize, the speed of light is finite. It's very fast, like I said, 186,000 miles per second. So if you were to travel at the speed of light, which you cannot do because you would turn into energy, it would take you a little over 4 years to reach Proxima Centauri. Now, if something is in the Andromeda galaxy, and that's 21 million light years away, it would take 21 million years at the speed of light to get here. So it's not happening. And even if you take all our radio and television signals and you showed a bubble of that electromagnetic radiation out into space, it would not be much farther out than the Oort cloud is right now, really. So, yeah, there's got to be other life out there. Will we ever see it? Will we ever contact it? I doubt it.
I think they're running the drones in New Jersey.
So I hear.
Thank you, George.
It was a great
You're welcome.
program.
Thank you. That's terrific.
Yeah.
Very good.
Thank you.
Really good updates. Thank you.
Thank you.
Thank you. You're welcome. Well, I have another meeting I got to go to, so I am going to sign off if that's okay.
Thank you so much.
Bye.
All right, take
Yeah.
care. Nice seeing you all.
Good night.
Good night.
That was good. That was very good. It's good to see everybody.
Makes you feel kind of meaningless.
There was a report today from the government on the drones in New Jersey and what they actually knew.
Oh, really?
Nothing exciting. They just identified the airplanes and such.
Did it mention that I trademarked Sky Witness?
They forgot to do that.
Oh,
I know they meant to.
the paperwork is still in process.
I believe you, though. We saw them too. It's good to see everybody.
Okay, should I end it for all of us then?
Yes, please.